everyone, and welcome to another UCLA SOLIDWORKS Student Leader Program video. In this video, we will be going over mass properties and how they will apply to the CSWA exam, but this content will also definitely be useful if you're doing any of your own designs or working off of any engineering drawings or basically in any situation. These are a very important and valuable set of skills to have. So in SOLIDWORKS, I have right now open is a part that I CAD'd myself. This was a part for holding a table in place. It was a folding table. And so as you can see on the left hand side here, we have no material specified. Now in order for SOLIDWORKS to calculate your mass properties for you, you have to have a material defined. Because mass properties will take the volume of your part, multiply it by the density of your material, and then it will give you, well, the mass of your part. So in order to specify a material, as we said in previous videos, you just go to material, right click, edit material, and then out pops a lot of predefined SOLIDWORKS materials that you can select from. So we have everything from steel, iron, various alloys, rubber, even wood. So for the purposes of this demonstration, we're going to go with a very common alloy, very common metal alloy. It's going to be 1060 alloy. We select it, and out pops a couple of material properties. So you can select your units up here. Here we have an SI units, which is perfectly fine. And then down here, we'll have a couple of useful measurements I'll need to pay attention to. So these first measurements are very useful if you're conducting FEA or finite element analysis on your part. So elastic modulus, Poisson's ratio, shear modulus, mass density, tensile strength, compressive strength, yield strength. This last one is very useful for FEA, where it'll give you the maximum stress that the part will experience when you subject it to a load, and you need to compare this to your yield strength, which is basically the point at which the part fails. And you need to make sure that your part is not going to fail under the specified load. So then we have a couple of other stuff down here. Personally, I never used these before in FEA, but you may find these useful. But for the purposes of the CSWA, this is really the one value that I have to pay close attention to. It's called mass density. In this case, it's given in units of kilograms per cubic meter. So this is 2700. And if they give you in grams, just multiply this value by 1000. And you need to use this value to cross-check the mass density value that they give you on the drawing, just to make sure you're using the right material in your part. So we're just going to go ahead and select this by clicking apply, then click close, and you can see that it's updated in the left-hand tree here. It says 1060 alloy. And next what we're going to do is we're just going to go up straight to this top toolbar, click evaluate. And then you'll see mass properties. So you need to go ahead and click on mass properties. This is the box that you're going to use on your CSWA exam when they ask you what exactly is the mass of your part. And so, well, where are you going to find that? Well, you can see that right here. The mass of this part is 6.06 grams. Now, if you want to change these units, you can go up to options. You click options, and then you have a bunch of different, options of how your stuff is displayed. So you can use scientific notation, and in this case you can switch it to custom settings, and I can set the length to something else. Mass, say I want it in, I don't know, kilograms, and then your volume unit, and if I click OK, then you can see that it's updated to 0.01 kilograms. You can also change the precision, so your number of decimal places, so you can rack it up. Click OK. And now you see a lot of precision in your mass value. But most of the time in the CSWA, they ask you for grams, and they won't ask more than 2 decimal places, which I think is the default for this document. Yeah, it's the default. So you'll just copy this value over to your testing client and put that in. Next, going down here, you'll see volume, surface area. And this is another thing they might ask you, especially in an assembly. When you're CADing assembly, they want you to find the center of mass. So in this case, it's a part, but you can see the center of mass in milliliters is negative 0.06, 8.06, and negative 8.25 millimeters. And this is calculated relative to this coordinate system right here. So now, what if you wanted to change this coordinate system? So for example, on the CSWA, if they ask you to set the coordinate system to a specific point. So you can see up here, it says report coordinate values relative to default. I have no other coordinate system specified, so it just defaults to this one. But if we close this, we can actually go to features, reference geometry, and we can create a new coordinate system. So this first selection is going to be the point at which your coordinate system is centered on. So I'm just going to click this edge right there. Sorry, I just wanted to select the point. And then the x-axis, so this is what your x-axis of your coordinate system is going to be collinear to. I'm just going to set it to this downward face, and you can flip it if you want. So you can see the little triad is flipping. Your y-axis, I'm just going to set it to this. And let's just say, for purposes of demonstration, I want to flip it. And the z-axis, I'm just going to set it to this. And okay, I'll just leave it unflipped. So if you click check, you can see that coordinate system 1 now pops up in your tree. And if you go to evaluate, go back to mass properties, and then you can change this to coordinate system 1. So you can see that it now selects coordinate system 1. And you can see that our center of mass in millimeters has also changed. So it's 7.44, negative 1.4, 9.06. If I change back to the default, you see it changed values. So this is useful only if your coordinate system has to be defined, and SOLIDWORKS is asking for the center of mass. So now you know how to change your coordinate system and specify it accordingly. Then all these other values down here, I've never seen them on the CSWA. You likely won't be tested on these. And the last thing I want to cover is also in the evaluate section, and it's right next to mass properties. It's called measure. Now this is very useful in case you want to double check a dimension that you didn't directly specify, say like in a sketch. Because normally with a sketch, if you specify a dimension, you can just double click on the sketch and then it'll show the dimensions that you put into the sketch. But in case, say I didn't know the height of this overall part. So what you do, you click on measure, and then out pops this little ruler with a little tape measure thing. And you can just click on one face, and you can click on another face, and it'll measure the distance between the two. So you can see the distance is 15.5 millimeters. Now, if you happen to select things that are not perfectly on top of each other, say I wanted to select this edge and this edge, then it will give you more dimensions to work with. So you can see that dz, or the distance in the z direction specified in the triad down here, dy, and as well as the length right here, which is the length of both of the edges, but also give you the overall distance. So most of the time you want this overall distance, but maybe in this case, I don't know, you wanted to find out the height difference between these two edges, you wanted to find out the z difference between the two edges, so on and so forth. Another thing that the measure tool can do is it can also measure circles. So if you click on the circle, it pops out its diameter is 4.5 and its center location relative to the origin. Another thing that it can do is also can measure distance between circles, so not only just regular edges, but also between circles. So it's the same thing, it measures between its centers. And really the last thing is, if you want to change how these measurements are displayed, just go up to this little INMM, and this gives you the document. This gives you the precision settings. And if I click use document settings, it's all grayed out, but use custom settings. Say I wanted to change it to, I don't know, let's say centimeters, and I want to change the precision, I can do that right here. Angular unit, say I wanted radians, and okay. And you can see it's changed to centimeters. Yeah, so that's basically all of the measuring tool that you might want to use on the CSWA. Again, this is really used only if you want to double check a dimension with a drawing, but the dimension is not explicitly created inside of a sketch, so you can't directly reference that. So this measure tool is just a really quick thing to pull out to double check those dimensions. Well, thanks for watching. This has been mass properties as well as the measuring tool in SOLIDWORKS. Two very useful tools that you would definitely use on your CSWA exam. Always remember to check out our website for the download for these parts if you want to follow along and rewatch the video again. And make sure to join our Slack channel, which is also listed on our website as well as down in the description if you are a UCLA student. And we'll see you next time.